We're going to use coordinates and properties of quadrilaterals to identify the quadrilaterals. So when we're looking at using coordinate calculations, we're going to use a couple of different things. So we're going to use the slope to identify pairs of parallel lines because they have the same slope. Then that's going to narrow it down. If we have two pair of parallel, it's one of our parallelograms. And we once again look at the slopes to compare consecutive sides to see if we get right angles. Opposite reciprocal slopes will be perpendicular to get right angles. And we're going to look at the length of a pair of consecutive sides because if consecutive sides are congruent, then all sides are congruent. If we only had one pair of parallels, then we're going to do the length of the non-parallel sides to see if we're isosceles trapezoid. And if there were no parallels, then we're going to calculate the slopes of the diagonals to see if they are perpendicular to make a kite. And if none of those things happen, then it's just none of our special quadrilaterals. We're also just going to use the properties themselves to identify our shapes. So you really need to make sure that you have this properties page completely filled in. So our first set of problems is we're going to have a property and we're supposed to identify all of the quadrilaterals that have this property. So our first property is both pairs of opposite sides parallel. So we find that one in the chart. And we see that this is a property that has been identified for the parallelogram, the rectangle, the rhombus, and the square. In problem 2, we have both pairs of opposite sides congruent. So we find this property in the chart, and we see that that has been identified for the parallelogram, the rectangle, the rhombus, and the square. For the next property, we're going to look at both pairs of opposite angles congruent. So we find that property in our chart. And once again, we see that this particular property has been identified for the parallelogram, the rectangle, the rhombus, and the square. The next property, exactly one pair of opposite sides parallel. So we find that property in the chart. And you have to be careful with this one because this one is the definition of a trapezoid. And notice that the trapezoid and isosceles trapezoid are identified separately. So this one is a property for all trapezoids as well as being a property for the isosceles trapezoid. Our next property is that exactly one pair of opposite sides are congruent. So exactly one pair of opposite sides are congruent. This one is identified as the property of what it means for the trapezoid to be isosceles. So this one is only true for the isosceles trapezoid, not all. Our next property is exactly one pair of opposite angles are congruent. So exactly one pair of opposite angles are congruent is identified as a property for the kite. The next property that we have is that the diagonals are congruent. So we find diagonals are congruent, and we see that this property has been identified for the rhombus Oh, sorry. For the rectangle, the square, and the isosceles trapezoid. So remember that theorem 616 is specific for the isosceles trapezoid. And our last and final property is the diagonals are perpendicular. So the diagonals are perpendicular has been identified as a property for the rhombus, the square, oh, that should be the square, and the kite. So this is listing all of the quadrilaterals that have that particular property. So this is just a matter of all the shapes within our chart that have that property identified. The next set of problems is a little more of a challenge because this time we want the most specific name. So we only get to give our shape one name. So we're going to list all of the things that are identified for that shape. So in problem 9, we're looking at diagonals that bisect each other. So the diagonals are bisecting each other. Each diagonal is marked into 2 congruent pieces. We also happen to have diagonals that are congruent because all 4 of these pieces are the same. So when we look at the shapes that this could be, because it is the diagonals bisecting each other, we can only look within our parallelogram section. So we only want to look within the parallelogram section. We have additional information, so it's not just the parallelogram. We do not have perpendicular diagonals. So since we do not have the perpendicular diagonals, this one leaves us with the rectangle. In the next problem, we have one pair of opposite sides parallel. So one pair of opposite sides being parallel. And we also happen to have base angles congruent. So when we look, our parallel sides makes this a trapezoid, and our base angles congruent makes this isosceles. So this is an isosceles trapezoid. Problem 11 starts out very much like problem 9. So we have that the diagonals bisect each other. So we're looking in the parallelogram section. Just like before, we have the diagonals being congruent because all 4 of them are marked exactly the same. So that means we're not just a parallelogram, and we can't be the rhombus. So we can't be the parallelogram, we can't be the rhombus because they don't have the congruent. And then when we look, there is an additional marking. We have this box which says that the diagonals are perpendicular, and perpendicular diagonals, bisecting diagonals, and congruent diagonals. So our rectangle doesn't have the perpendicular. So when we put it all together, we have the properties of the square. So everything we have is a property of the square. So our coordinate calculations. Our first step in the process is to find the slope of each side. So we have 4 sides that we're going to find the slope of. So we're going to start with PQ. So that's going to be y2 minus y1 over x2 minus x1. So 2 over 0 is undefined. We're going to work with QR. So this one's going to be 5 minus 2 over 5 minus 0. So this is 3 over 5. We're going to have the slope of RS. So this one is going to be 0 minus 5 over 2 minus 5 to get negative 5 and negative 3, or a positive 5/3. And last, we're going to do SP. So the slope is going to be 0 minus 0 over 2 minus 0 to get 0 over 2, which is 0. So we're looking for how many pairs are equal. And in this particular set, we have none of our slopes being equal to each other. So none of our slopes are being equal to each other. So that means that when we go to our next set of notes, we're going down here to step C, the kite or none. So we are either going to have a kite or we're going to have none of these shapes. So what we need to do now is get the slopes of the diagonals. So our diagonals connect non-consecutive vertices. So that means we're going to work with PR and QS. And once again, we're using the slope formula. So y2 minus y1 over x2 minus x1. So this is a slope of 1. And for QS, it's y2 minus y1 over x2 minus x1. So this is negative 2 over positive 2 to get a negative 1 over 1, or negative 1. And when we look, these are opposites, and negative 1 and positive 1 are reciprocals. So we have opposites and reciprocals. So this is the kite. So we start with our first set of notes, and we're going to do the slope of each side. So PQ is going to have a slope of 1 minus 1 over 7 minus 2 to get 0 over 5, which is 0. Side QR, x2 minus x1 over y2 minus y1 is going to give us 6 over 0, which is undefined. RS is going to be 5 minus 7 over 2 minus 7. So this is going to be negative 2 over negative 5 to get 5 halves. And last, we're going to do SP. So that's going to be 5 minus 1 over 2 minus 2 to get 4 over 0, which is undefined. And since we have two slopes that are undefined, we have one pair of parallel sides. So we're going to go down to the trapezoid section. So we're now down to it's either a trapezoid or it is an isosceles trapezoid. And at this point, we are now going to calculate the length of the non-parallel sides. So we're going to work with the non-parallel sides and calculate the length. So for PQ, we're going to do x2 minus x1 squared plus y2 minus y1 squared. So this is going to be the 5 squared plus 0 squared. So this is 25 to get an answer of 5. And we're going to work with RS. So our distance formula, this is going to be 2 minus 7 squared plus 5 minus 7 squared. So this is negative 5 squared plus negative 2 squared. So this is 25 plus 4 to get the square root of 29. And the square root of 29 is approximately 5.4. Since these are not equal, we do not have the trapezoid. We have, or the isosceles trapezoid, we have a trapezoid. So this is the trapezoid. Because the legs are not equal, it is not isosceles. One more example. So we're going to start with step 1. We're going to find the slope of all 4 sides. So we start with PQ, y2 minus y1 over x2 minus x1. So this is going to be 2 over 4 to get 1/2. Then we do QR. So this is going to be 3 minus 9 over 8 minus 5. So this is negative 6 over 3 to get negative 2 over 1 or negative 2. RS is our next side. So 1 minus 3 over 4 minus 8 is negative 2 over negative 4 to get 1/2. And last we have SP. So we're going to do 7 minus 1 over 1 minus 4. And this is going to be 6 over negative 3 to get a negative 2 over 1 or negative 2. So when we look, I have 2 that are a slope of 1/2, and I have 2 that are a slope of negative 2. So this is 2 pair of parallels. So we're going to go down to the parallelogram section. So we have either a parallelogram, a rectangle, a rhombus, or a square. Now, for the next calculation, we don't actually have to redo any calculation. For this next step, we're simply going to look at the slopes again, and we're going to see if our consecutive sides have slopes. So this time, we're comparing side to side. So we're looking at 1/2 and negative 2 over 1. They are opposites and they are reciprocals. So this means that we have perpendicular, which means that we have right angles, and our parallelograms with right angles are the rectangle and the square. For the next part of this, we're actually going to have to calculate. So this time we're going to do the length of one pair of consecutive sides. So we're going to pick sides that have a common endpoint. So PQ has a common endpoint with QR. So both of these have the common endpoint of Q. So we do the distance formula. So for PQ, that's going to be 5 minus 1 squared plus 9 minus 7 squared. So this is going to be 4 squared plus 2 squared. So this is going to be 16 plus 4. This is our square root of 20, which is approximately 4.5. For QR, we're going to do 8 minus 5 squared plus 3 minus 9 squared, all under the square root. So this is going to be 3 squared plus negative 6 squared. So this is 9 plus 36, which is 45. And the square root of 45 is approximately 6.7. So these are not equal. So squares have all their sides equal. Since these are not equal, we have a rectangle. So use each calculation following the steps within the notes to compare to get your shape.